everyone. Every day we hear different types of sound. Now, what exactly is sound? Sound is a form of energy which produces a sensation of hearing in our ears. Now, let's perform an activity to understand it more clear.
Hello everyone, today we are going to do a demonstration about production of sound. To do the same, we are having two devices called tuning forks. Each one have different frequencies. Can you guess which one has the lower frequency and which one has the higher? You may not. Let's test this by banging each one of them on table. Let's start with the little one first.
Ooh, yeah, that hurts my ears from here.
As you can hear, it has kind of high frequency. Now let's test the longer one. Now we can conclude that the longer one has a lower frequency. The longer the tuning fork is, the lower the frequency. Frequency is basically the number of vibrations per unit time. Now we are going to do a really interesting thing. To do this, we have to take a bowl of water. Now we have to bang the tuning fork on the table
And I'm going to put it in the water.
and put it in the water. As you can see, the vibration actually displaces the water from the bowl. Because of vibration produced by tuning fork, the molecules of water also starts moving along with the vibration of tuning fork. Now let's try with the little one. Now let's try again with the little one too. As you can see, it also worked very well. By this we can conclude that the sound is produced by only vibrating objects. Thank you.
From the above activity, we concluded that sound is produced by vibrations. Sound can also be produced by plucking, scratching objects. Now, what exactly is vibration? Vibration is a rapid to and fro motion of an object. Now, you will be thinking that in how a human produces sound. In a human body, sound is produced by vocal cords. Vocal cords vibrates, thus producing sound. Propagation of sound. To understand this topic better, you have to learn what exactly is a medium. The object through which sound is transmitted is known as a medium. When an object produces sound, it forces one air molecule to move forward, and again that air molecule forces another air molecule to move forward. This happens again and again until the sound reaches your ear. When an air molecule performs back and forth motion, it creates a region of low pressure and high pressure. The region of low pressure is known as rarefaction and region of high pressure is known as a compression.
What is wave and what are its types? A wave is a disturbance that passes through a medium and set the particles of the medium in motion. Sound wave is characterized by its motion and are called mechanical wave. It is of two types, longitudinal wave and transverse wave. Longitudinal waves are the waves which travel in direction parallel to the direction of propagation. These waves are also called mechanical wave. These waves produce back and forth movement. When a longitudinal wave travels, it creates two types of region. Compression and rarefaction. Compression is a region of high pressure in which the movement of the particle are in forward direction. Rarefaction. Rarefaction is region of low pressure in which the movement of particle are in backward direction. Transverse wave. Transverse waves are the waves in which the particles of the medium vibrates up and down at right angles. When the amplitude is maximum, it is called crest, and when the amplitude is minimum, it is called trough.
Hello everyone. Now I will explain you speed of sound in different medium. It is not that simple as you think. Sound propagates through a medium at finite speed. Speed of sound depends upon the nature of that substance known as material medium. Speed of sound is not same in all objects. Speed of sound also depends upon the temperature of that medium. More the temperature of medium, more will be the kinetic energy, more will be the speed of sound. Sound travels the fastest in solid, then liquids, then gases. Speed of sound in air is nearly about 344 meter per second. Objects that travels faster the speed of sound are known as supersonic objects. The tremendous air pressure variations caused by the shock waves produced a loud burst of sound known as sonic boom. This sound is enough to make us deaf, shatter glasses, and even damage buildings. Thank you.
Everyone, now let's study about the characteristics of sound. First, we have wavelength. The distance between two consecutive compressions or two consecutive rarefaction is known as the wavelength of the sound. SI unit of wavelength is meter. It is denoted by the Greek letter lambda. Secondly, we have frequency. It is defined as the number of oscillations per second. SI unit of frequency is hertz. Frequency also determines pitch and shrillness of sound. Then we have time period. Time period is defined as the time taken by a particle to complete one oscillation. Then amplitude. The magnitude of the maximum displacement in the medium on either side of the mean position is called amplitude of the wave. The SI unit of amplitude is decibel, or we can say decibel. Amplitude also determines the loudness of the sound. Then we have timbre or quality of the sound. Quality or timbre is the characteristic of a sound which enables us to distinguish between two different sounds. These characteristics of sound also help us to recognize our friend from his voice without even seeing him. The quality of two sounds of the same loudness and pitch produced by two different sources are distinguishable because of different waveforms produced by two sources. Then lastly we have intensity of the sound. Intensity of a sound is defined as the sound energy transferred per unit area per unit time place perpendicular to the direction of propagation of sound. That is, intensity of sound is equal to sound energy upon time into area. Intensity of a sound is an objective physical quantity. It does not depend on the response of our ears. Thank you.
The average human ear has an audible range between 20 Hz to 20,000 Hz. What this means is that you can hear the sound only that has frequency between 20 Hz to 20,000 Hz. If you can take the sound that has frequency beyond this range, you will not be able to hear it. And this sound whose frequency is less than 20 Hz is called infrasound, and whose sound that has frequency is greater than 20,000 Hz is called ultrasound.
Now, the range varies from person to person. For example, young children, they can even hear up to 30,000 words, and as you get older, as age increases, the range reduces and is not just depend on its even normal people, right? Their range varies from person to person. In fact, you can use an app. You can use that app to see what frequencies you can hear and what frequencies your friends cannot hear. Also, animals have different ranges, different audible range. If you take wild and elephants, for example, they can go below, they can make sounds whose frequencies are lesser than 20 Hz. And if you take example like dolphin and bats, they create sound whose frequencies are much higher than 20,000 Hz.
Now I'll tell you about applications of ultrasound. So first, ultrasound is generally used to clean parts located in hard to reach places, for example spiral tube, electronic components, etc. Objects to be cleaned are placed in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequency, the particles of dust, grease and dirt get detached and drop out. The objects thus get thoroughly cleaned. Second, ultrasounds can be used to detect cracks and flaws in metal blocks. Metallic components are generally used in construction of big structures like buildings, bridges, machines, and also scientific equipment. The cracks or holes inside the metal blocks, which are invisible from outside, reduces the strength of the structure. Ultrasonic waves are allowed to pass through the metal block and detectors are used to detect the transmitted waves. If there is even a small defect, the ultrasound gets reflected back. Ultrasonic waves are made to reflect from various parts of the heart and form the image of the heart. This technique is called echocardiography. Fifth, ultrasound scanner is an instrument which uses ultrasonic waves for getting images of internal organs of the human body. A doctor may image the patient's organs such as the liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect abnormalities such as stones in the gallbladder and kidney or tumors in different organs. In this technique, the ultrasonic waves travel through the tissues of the body and get reflected from a region where there is a change of tissue density. These waves are then converted into electrical signals that are used to generate images of the organ. These images are then displayed on a monitor or printed on a film. This technique is called ultrasonography. Ultrasonography is also used for examination of the fetus during pregnancy to detect congenital defects and growth abnormalities. Fifth, ultrasound may be employed to break small stones formed in the kidneys into fine grains. These grains later get flushed out with urine. Now, I hope you all have known about the applications of the ultrasound.
The sound heard after getting refracted from a rigid obstacle is called echo. It is found the sensation of any sound persists about 1/10 to 1/20 second in ear. After that, the existing sound dies off. This time interval is known as the persistence of sound. It varies from person to person and also with the frequency of sound. Persistence of sound even after its production is stopped is called reverberation. When a sound is produced in a big hall, it gets reflected from the walls and travel back and forth. Due to this successive reflection, the sound persists in the hall. Now you know these, but what are their applications? Some examples are megaphone, stethoscope, sounding boards in cinema halls, etc.
Now I will explain you laws of reflection of sound. Laws of reflection of sound is same as laws of reflection of light. First, it states that the incident ray, the reflected ray and the normal all lies on the same plane. Secondly, it states that the angle of incidence is always equal to the angle of reflection.
Have you ever wondered how a human ear works? It is not that simple that you think. Our ear is divided into two parts, outer part and inner part. Our outer part is called pinna. It collects sound from our surrounding. Without it we can't even hear. Further, the sound travels through a canal known as auditory canal. Now, that sound gets stuck with eardrum, and that eardrum transforms that sound into vibrations. After the eardrum, three bones are there named as hammer, anvil, and stirrup, also known as malleus, incus, and stapes. Now, you will probably thinking, what does these bones do? They amplifies the vibrations which were produced by eardrum. Further, in the inner ear cochlea was there. Cochlea have a special kind of fluid in it, in which our auditory nerves are dipped. Now that vibrations in cochlea and the cochlea transforms that vibration into electrical impulses since our brain can only understand electrical signals. Our auditory nerves transfer that electrical impulses to our brain and our brain interprets that signal and understand that. And this is how a human ear works.